In this video, we're going to discuss an example involving uniform motion. So let's go ahead and read the question. So Sarah and Jill go out for a run. Since Sarah runs slower than Jill, Jill gives Sarah a 30-minute head start. If Sarah runs at 5 miles per hour and Jill runs at 6.7 miles per hour, how long will it take Jill to catch up with Sarah? Okay, so the first thing you need to remember for these sort of questions is the distance equation with regards to rate and time. So distance equals rate times time. If you ever forget this equation, one thing that you could remember is, miles, which is the unit for distance. So miles equals rate, right? Rate is in miles per hour. And then if you multiply that by time, or hours, okay, you see how the hours cancel, and you're left with miles equals miles. So, if you ever forget this equation, you can easily derive it yourself. Distance equals the rate times the time it takes you to move, right? So, let's go ahead and get started with this question using that information. So let's see. We have so we're trying to find how long it takes for Jill to catch up with Sarah. All right. So what's the distance that we're interested in finding? We're trying to find the distance in which Jill and Sarah have run for the same amount of time. Right. So let's go ahead and define our distance, to equal the distance at which the distance at which Jill and Sarah meet. Okay, so at which Jill and Sarah meet. Okay, that's going to be our distance. All right, and then time, t. This is, we're interested in knowing how long it takes Jill to get to Sarah, right? So our time then should be the time that Jill is running, right? So this is going to be the time that Jill runs. Okay, and remember, so the unit for the distance is going to be miles, and the unit for time is going to be hours. It has to be miles and hours because we're given the rate in miles per hour. Okay, so the rate. Now we're given two different rates. The rate is 5 miles. Oops. 5. Let me go and write that again. 5 miles per hour for Sarah, and 6.7 miles per hour for Jill. Okay. So let's see. What's the distance that Sarah runs? Okay, so let's break this up. So the distance that Sarah runs. So at the time that Jill and Sarah meet, the distance that Sarah will have run is d equals RT. For her, it's going to be 5. And then what's her time? Remember, time is the time that Jill runs. But Sarah's already been running for half an hour before Jill even starts running. So her time is going to be the time that Jill's been running plus an extra half an hour, 0.5 of an hour, right? So don't say plus 30 because that wouldn't make sense, because remember, you really have to keep track of your units in these sort of questions. If you're to say plus 30, it would really mess up your results. We're talking about time. It's not in minutes, it's in hours. So this is half of an hour, 0.5. Okay, so that's the distance equation for Sarah. And then let's talk about the distance equation, distance that Jill runs. And then that's going to be d equals 6.7 times t, right? Because t is the time that Jill runs. All right, so now we have two equations here that both involve d, and this d is the same thing. It's the distance in which Jill and Sarah are meeting each other. So now I can just set both these equations equal to each other, okay? So I can basically, use this and plug it in for that d there, right? So I'm going to go ahead and say, so 6.7t equals 5t plus 0.5. Alright, so now it's just algebra. All I have to do is find what t equals. Alright, so I have 6.7t. First thing I'm going to do is go ahead and distribute this 5 into the parentheses. So I'll get 5t plus 0.25. And then I'm going to subtract 5t from both sides of the equation. Okay, so minus 5t minus 5t. And what I'm left with on this side of the equation is so it's minus 5t, so 1.7t. And what I'm left on this side of the equation is just that, oops, I made a mistake here. 5 times 0.5 isn't 0.25, rather it's 2.5. Okay, I just misplaced my decimal place there. Okay, so on this side of the equation I should be left with 2.5. Okay, and now I just need to divide both sides by 2.5. So I'm going to divide, oops, not by 2.5, sorry. I'm going to divide both sides by 1.7. Okay, trying to get t by itself, right? So I'm dividing, trying to get that canceled, so I just had the t there. And so then I'm left with t equals 0.68. Alright, and so I know that the time it will take for Jill and Sarah to be running together is 0.68 of an hour. So Jill meets Sarah after 0.68 hour. Or you could convert that to minutes by multiplying it by 60 minutes, and what you'll get is 40.8 minutes.